All right, here we have lesson 8. This is where we're just transforming these trig equations again. Now we're bringing in all of the different pieces. So we're also translating left and right and up and down and all that good stuff. But again, basically it's the same stuff we've just been doing all course. So it's nothing really all that surprising. This is going to be horizontal translation, right 30 degrees. This one's going to be a vertical translation up 2. This is going to be horizontal translation left 60 and down 1. And then this is going to be up 45 and right 45. Again, I need to be able to deal with it in replacement mode or mapping mode or the combination thereof where I've got mapping and replacement going on. All those potentialities are all there, and I need to be aware of and responsible for all of them. Same old. Now in trig we call them horizontal phase shift and vertical displacement. Whether you call it horizontal phase shift and vertical displacement or just still call it translations, I don't care. So just so long as you're straightforward with what you're doing, then we're all set and all good. Okay, so this thing is 0 and 0, right pi quarters, 0, 0, up 5. This is going to be down, sorry, this is my left 3 pi halves, and this is going to be down pi. Here I'm going to have right C units, up D units, and same thing, right C, up D. The thing we want to note there is that it doesn't matter whether they're stretched or not. The stretches play no impact on the values, assuming that I'm not a rage question, right? We want to be careful that we don't have something like this, sine of 2x minus 4. That would be a problem. I'd go, anger, and then fix it by factoring that out to there. Hopefully that still makes sense, and you're not going, what the hell's a rage question? If you are, look back at the transformation videos. You should be all set. All right, so we saw what all those things did. We were aware of our rage question. We're good to move on. Now, the finding the C value, this phase shift part, is actually the hardest part of doing this graphically. This is the note, so it kind of has all of these different things, and it reminds us of all these pieces. Feel free to read through it. This is the summary of the effects of the A, B, C, and D. So basically everything does just like we knew it would beforehand. The only difference is that now we're doing a trig and not the other pieces. So if I wanted to write this down, if I've got A, B, C, and D, I wanted to write a cosine function with a horizontal phase shift of 75. It's just going to be y equals 1 cos of 1 x minus 75 degrees plus 0. That's my basic. Now if I want phase shift of 3 pi fifths to the left and 4 up, it's just going to be y equals sine, if it says so there, of x plus 3 pi fifths, and then plus 4 outside. So general, when they've given us the equation, it's pretty straightforward. So all we have to do is throw it in our calculator, if nothing else. But amplitude is 2. My period equals 2 pi over my b, just 2 pi thirds here. It's been shifted pi left and 4 down. Again, same tricks here. My amplitude is just 2/3. It doesn't matter that it's negative, it's just the entire value. My period is 2 pi divided by my b, which is 1/4. 2 pi over 1/4 is the same as 2 pi times 4 over 1. So it's 8 pi as my period. And then it's been moved pi 12ths right, and 3 up. Those are my phase shift and then my translation. Here it's the exact same thing, except we have a range question. So I'm going to factor out my 3, this is x plus pi thirds minus 4. So really the only difference is that this moves left pi thirds and not pi. Rage. Angry. They're trying to trick me. Again, same thing here. 2x minus pi quarters. And now that I've satiated that range, I no longer have to be angry. But this is going to be pi quarters to the right. This is the harder part where they give us the graph and then ask us for the equation. So in general, you want to work from the outside in. So if I had all of these, including a d value, I can see that there isn't a d value yet. The d value is 0 because the midline is at the x-axis. So now, in general, there's 4 possible graph types I can use. Positive sine, negative sine. Positive cos, negative cos. And really, they're all the same. They're just horizontal translations of each other. So once we decide which of those we're using, that's how we determine our horizontal phase shift. And again, that's usually the hardest part for people. So if I have this equation, and I'm trying to get it as y equals a sine x minus c, and my a is greater than 0, so it has to be a positive one, I know that the template I'm using has to be this. So the original graph started here, and then went up, and then went back down, and then was down here, and then went back up, and did something like that. So I can see I don't have to worry about period. The period is 2 pi. It just says so. There's no b value listed there. My amplitude is 4. And what I can see here is that it got moved 2 blocks to the right. 2 squares to the right. And what's to the right is that pi halves. So, which is not quite pi halves is 3 boxes. Now I only need to move 2 boxes. So if there are 6 boxes in pi, then each of these boxes is pi 6. Again, because there are 1, 2, 3, 4, 5, 6 boxes to get to pi. Each box is pi 6. So if I need to move 2 units or 2 squares to the right, it's going to be 2 times that, which is 2 pi 6th or pi 3rd. It's going to be 4 sine of x minus pi thirds. Same thing here, except now they want it as a negative a value.
Yeah.
All right, so picking back up here again, there's just the 4 starting points. So here I've got my negative sign. The negative sign has to start like that, midline going down. So it's going to be either this one as my starting point or this one as my starting point. And this is where there's an infinite number of possible answers, but they make it less by saying minimum horizontal phase shift. So the minimum phase shift would be 4 boxes to the left. We already decided that each box was pi 6ths, so 4 times pi over 6 is 4 pi over 6 is 2 pi over 3. Good, yeah? Makes sense, hopefully? And again, all that's different, everything else is the same except for my c value. So this is my c value. So the overall thing would be 4 sine x minus 2 pi thirds. If I'm doing it like a positive cos, it just has to start there. That's going to be 5 units over. So it's going to be 4 cos x minus 5 pi over 6. Now, actually, I just realized I made a mistake up here when I rewrote this one. This is my negative sign, so that should be negative 4. My a value always has to match. Here it's a positive a value, positive a value. Here it's a negative a value, and my negative cos starts at its minimum. So this thing has to start at its minimum, which is right here, or 1 unit left. So y equals 4 cos x plus pi 6. Oh, and negative, because that's negative there. So again, there's an infinite number of possible answers. It just depends on which way the graph wants it. Does it want you to find it as a positive sign, positive cos, negative cos? If it doesn't tell you, then you can just choose whichever of the 4 you want. And I'll have that lots of times on my test, where you can just choose whichever representation you like most. So here it's a is greater than 0, and I think they say sine somewhere. Yep, there it is. So it's a sine graph, and it's greater than 0, so it has to start midline going up. Again, my default is that. That's my Joe average, so it got pushed 1 unit to the left. In this case, though, 3 of my units is pi, so each thing is pi thirds. So amplitude is from 1 to negative 5. That's a span of 6. Divide that by 2. That's 3 is my amplitude. My period, if I look from max to max, this is 2 units over, and this is 2 units over, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 units, and each 3 units is pi. So 12 times pi over 3 equals 4 pi. So my period in this case is 4 pi. My minimum phase shift, again, I have to always go relative to your midline. That's what throws people off. If they don't choose their midline right, they get the wrong value going on there. But so relative to my midline, I have to move 1 unit to the right. Each unit is pi thirds. And my vertical displacement is down 2. So now the equation is just 3 times sine of, my b value is the only one I actually need to figure out. My b value is 2 pi over my period, and my period's 4 pi. 2 pi over 4 pi equals 1/2. So 1/2 x minus pi thirds minus 2. Now, if it was so all of these other things are still the same. Amplitude is still 3. This is still 4 pi. Minimum horizontal phase shift is going to shift, but displacement is still going to be down 2. So all the other values are exactly the same, but if I want a negative sign, it's got to be that starting point. So which one's closer? That is. And that's 5, so it's going to be 5 pi thirds to the right, which means this is going to be, oh, cosine. Look at me go. All of this information is for this thing. So this is going to be negative 3 sine of, the period is still the same, which is going to be 1/2, right? The b value. 1/2 x plus 5 thirds, plus 5 thirds, plus 5 thirds. No, minus 5. I got signs backwards all over the place here. To move this left, that really ought to be plus. And then to move this right, that ought to be negative. Whew. Long day, long day. That's that. Now let's erase all this information, because what we now want is, actually all we really need to erase is that. All the other information is still the same, except now we're doing it as a positive cosine. positive cosine starts at its maximum value, which is right here. Remember that each square is pi thirds, so it's going to be 2 pi thirds to the right. And now it's going to be positive 3 cosine of negative, not negative, 1/2 x minus 2 pi thirds minus 2. There we go. And now lastly, if I was doing it as a negative cosine, they're not asking for negative cosine? Oh, I think they did it at the bottom. Yeah. If it was a negative cosine, it's going to be this one or this one. Which one's closer? Well, this is. So 4 pi thirds. So that would be negative 3 cos 1/2 x plus 4 pi thirds minus 2. And that's going to be that value there. So considering these, which things affect domain and range? The only thing that affects the domain is, well, nothing. Because the domain for all of those graphs is x is known with the reals. The range here is my a and my d. In fact, you could write the range as d minus a is y and d plus a. So you take your midline, your d value, and either add or subtract a from it, and that gives you your range. Your amplitude is just a, your period is affected by the b. It's not equal to b, but it's affected by the b. And then your zeros are affected by your b, c, but also a and d, because if we move it up or down, it'll change the zeros. Even change whether there are zeros or not. So maximum, minimum values, well, we just did that. It's your d plus your a, and your d and minus your a. Those are going to be the values there. So just looking at this, the range is going to be negative 4 plus 3 and negative 4 minus 3. And actually, I've got these backwards. That should be over there. Negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. So that's my final range there. Hopefully that makes sense. Again, if not, if any of those parts are getting confusing, come on in, get help, we'll make it good.